Hey guys, Aditya here, and today we're just going to be going over a quick tutorial on how to use port view in the EV3 Mindstorm to Brick. So port view is something that can't be accessed through the EV3 Mindstorm software, so you're actually going to have to use your brick for it. So right over here, we have my brick, and if you look over here, we also have a color sensor, as well as a touch sensor. So port view is really important for detecting what sensor values are being outputted by your sensor. And these kind of all vary by sensors. So I'll show you what I mean. So right now, this is what you'll open as soon as you kind of boot up your robot. So you'll see programs over here. You'll see the name of your robot. So click the right button 2 times. In order to go over to port view, you see port view, motor control, IP control, and brick program. Just go on over to port view. And right over here, you can already see a bunch of sensor values depending on where your sensors are inputted. So on my robot, the color sensor is on 2 and the touch sensor is on 3. So if I want to go to 2, I just click the right button once. And right over here, I can see the value that my color sensor is reflecting. So as of now, it's set to the color sensor reflect percentage. So as we know, white actually reflects a lot of light, so it'll give a higher percentage. This, as you can see, is a white desk, so it'll be reflecting a lot. Whereas if I were to move my robot forward onto this black mousepad, it only reflects 1%. So this will be really important when we delve into color sensors later on, in the sense that the robot can differentiate between colors based on what percent of light it reflects. So now we can also look at the color sensor values, the touch sensor values. So I have my touch sensor over here, and currently it's at 0, meaning that the touch sensor has not been pressed yet. But if I press my touch sensor, the value changes to 1. So in that way, touch sensor or port view is really important, but specifically for the color sensor, because based on what color sensor you're using, these values can actually vary. So I've had color sensors before in which a white table like this will give me 70% reflecting percentage, and a black mousepad will give me 10%. On this one, it's 25 and 1. So it can vary for all of them. So make sure before you even use your touch sensor, try this out and see what values you get and keep those in mind. So one more thing about the touch sensor is that you can actually alternate between the modes of the color sensor. So right now, we're primarily going to be using color reflect, which you can see over here. But there are also 2 other methods or 2 other modes that you can use with the color sensor, being ambient and color. So if we go over here, click the center button, and then you'll see color reflect, ambient, and color. And then click the down button and select ambient. So if you see over here, ambient only gives us 2%, 2 to 3%, and it'll give us about 1%. So in general, reflect tends to be a lot more accurate. So we're going to be using that for the majority of the time. The only difference is that ambient doesn't shine any light, but we'll get into that later. And one last mode, if you click the center button, there we go, and then go over to color. So right now, there we go. So as of now, the color sensor is returning a color value of 6. And in the EV3 Mindstorm software, 6 is the code for white. So this is also helpful. Typically, we're going to be alternating between color and reflected light intensity. But if you just want to use color, this means that when the color sensor is looking at a white table, it reflects 6, which is white. Whereas if we move this forward a little bit, it gives us 0, which is the color for black. So yeah. Hey guys, now we're going to be going over the color sensor. So what the color sensor is it can be used to detect a certain color, a certain reflected light intensity, or a certain ambient light intensity. But they all kind of go under the same category. So in general, you'd be using the color sensor to detect a color, and then do things accordingly based on whatever color the robot identifies. So a very popular program is going to be driving until you see a black line, and then moving backward and then turning around or taking a 180-degree turn. Another one is also a line following program in which you'd be following some sort of blue line or green line based on what color the robot thinks it is. So it's a really useful block, and today we're just going to be going into how to program it. So if you look over here on the yellow section, you can see there's a color sensor block. If you just want to go ahead and drag that out. But we're not going to be using this because, as I mentioned before, similar to the touch sensor block, this is only used to actually measure a sensor value, as opposed to the block that we're going to be using for now, which is the wait for color sensor block, which is right over here. So the cool thing about the color sensor is that when you're programming it, it uses the exact same format as the touch sensor. The only difference is that you'd be changing the sensor. So if you guys remember what that was, all you got to do is drag out your move tank or move steering block, put it to on, drag out a wait block, and now we got to go over to color sensor, compare, and as you can see here, there are actually 3 modes that we can select from. So first of all, color. If we select on color right here, we can see that there are 7 colors that we can choose from. No color, black, blue, green, yellow, red, white, and brown. So basically, what this will do is the color sensor will try to best identify what the color is right now. So for instance, my robot is currently on a white desk. So right now, if I were to use the color sensor, it'd probably detect a white value. Whereas if I moved it over to my black mouse pad, then it would detect a black value. And it can also be used to detect several colors at once. So that's one mode, and this is just used to detect colors. But I'd say unless you have really good lighting, to stray away from this and instead use the other method, which is reflected light intensity. So what reflected light intensity does is it shines the color sensor. The color sensor shines a light on whatever the platform is, and it'll return a certain percentage of reflected light. So white reflects a lot of light, or white colors, lighter colors reflect a lot of light, so you'd be getting a very high percentage, whereas darker colors, like black, would not reflect as much light. So this way you can clearly tell the difference as opposed to, because when you're using the color block, the robot itself has to determine what color it thinks it is. So maybe if you have a color that's kind of like in between green and blue, it wouldn't really be able to determine what color it was. Instead, you'd probably want to use reflected light intensity. We also have ambient light intensity. This is kind of similar, except it doesn't actually shine a light on whatever the surface is, and as a result, it tends to be slightly more inaccurate. So I'd say for the most part, stick with reflected light intensity or color. So for now, I'm just going to go with reflected light intensity. And as you can see over here, there are a bunch of parameters. So first of all, we have this one, which is an operator. So right now, this is the less than symbol, but we can also make it greater than, equal to, not equal to, greater than or equal to, and etc. So this is useful just depending on what scenario you're in. For now, we're just going to stick with less than. And right over here, we have the threshold value. So this can be slightly tricky to determine, but if you guys watched the last lecture on port view, basically if you go over to your robot and then select port view, you can find what kind of the threshold value is for certain colors. And I would suggest doing this with white and black. So on my robot, at the very least, I believe white gives me, let me check right now. So the way you do this is just by taking your robot and then just placing it on a white surface and then doing it on a black surface. So a white surface gives me, and I'll comment this down. So a white surface gives me about 14% reflected light intensity. Whereas if I move it to a black surface, it gives me 1%. So go ahead and record these values. And basically the threshold value that you'll want to identify is going to be something in between those numbers. So basically find the average, in which case this would be around 7 or 8, and that'll be your threshold value. So I'm going to put it at 7. And now that we have our threshold value, we take our move tank block and set it to off. So what this program will do is the robot will move forward until it sees a value. It'll wait until it sees a reflected light intensity less than 7%. In other words, a very dark color. And then once it sees that, it'll stop. So that's what the program will do. So if you guys want to go ahead and run this, feel free. So yeah, so that's one method of doing it. You can also do this with the color. So if you change this, compare, and then go over to color, deselect this, and select black. So try running this program and seeing if it works, but basically what this program is supposed to do is the robot will go forward until it sees black. You can also select multiple colors, so maybe like black or brown, just to account for that error, but I would just do black for now. So it'll go forward until it sees black, and then it'll stop. So that's what this program will do. But let's say you're on a black surface and you want to identify a white line. Then what would you do? So the answer here is fairly simple. We would go over to color sensor, compare reflected light intensity, and then instead of saying less than, we would say greater than, or greater than or equal to. And then just set this to our threshold value. So what this means is that the robot will go forward until it sees, and it'll wait until it sees a threshold value that is greater than 7. Which means that, so we already know that a black surface gives us a reflected light intensity of 1%. So currently when we're going to be driving, when we're driving on a black surface, it'll be around 1-2%. And then as soon as it sees a white percentage, or as soon as it sees a white surface, that percentage will go all the way up to 14%. Which means that we want the robot to go forward until it sees a surface that is white, a surface that is greater than 7% light intensity. And then it'll stop. So that's what that program does. Alternatively, we can also use the color, compare color, go ahead and deselect this, and then just select white. And go ahead and run this program and see if both of that works. Alright, so lastly, there's one other method of doing it, and once again, this is really similar to the touch sensor, in the sense that it uses a loop. So go ahead and drag on that loop over there, and then just put in a move tank or move steering block. Set that to on, and currently this program wouldn't really execute anything, it would just keep on going. So change this from unlimited to color sensor, and then you can choose whatever you want, color or reflected light intensity. I'm just going to do light intensity for now. And just like that, we have everything set to default. Set that to 7, and keep in mind that this will change, so make sure to check what your intensity values are in port view prior to running this program, because they could be totally different, and they probably are going to be different. And if we run this program, it'll basically just go forward until it sees reflected light intensity less than 7, until it sees the black surface. And as always, we can alternate this with color. Just select the black color. So that's how that works. And yeah. So for the challenge, what I want you guys to do is to move forward until you see a black line. And then when you see the black line, go backward for one rotation, take a 180-degree turn, and then go forward in the other direction. And then alternatively, if you also want to, try doing this on a black surface and identify a white line. So yeah, I'll see you guys next time.